hope we're live. Cool, let's get started. So, the entire motive of this live stream is so that I become accountable for myself, so that I can do my DSA prep with considerable amount of responsibility. And the first problem I'm solving is set matrix 0. Given a matrix, if the element in the matrix is 0, then you'll have to set its entire column and row to 0 and then return the matrix. So I'll show you till how much we had done. So yeah, so I believe till here it must be good enough to print an array. Let me run this function. So we compiled it. Let's run it. Let me enter 9 digits. Yeah. So as we see, as we enter the 9 digits, we get a matrix returned with 1, 2, 3, 4, 5, 6, 7, 8, 9 as the elements. Alright. Now the next steps will be so we now know how to print a matrix. Like we know we can print n number of like we can enter n elements and it will represent in the form of 3 cross 3 or 4 cross 4, or let's say to generalize n cross n matrix. Alright. I've seen the approach, I just need to do it myself now. I know the approach. I essentially need to code it myself. But I don't think I am doing matrices the correct way, because it is just represented in the form of matrix, but actual functions are used which are there in arrays. So ideally I should represent it like this, right? Matrix Java 2D arrays. Yeah. Print a 2D array or matrix in Java. So oh, I didn't know something like MAT also exists. I thought only arrays and 2D arrays exist, but matrix is also something. Or it. No, no. It is just a variable name, and the thing which we are using in background is just a 2D array, nothing else. I is then matrix.length I plus plus j is 0. So MAT of I j. Okay, so we can define int matrix as and 12, right? This will be a function to print 2D matrix. So two nested loops. जैसे आई क्या होगा, 0 से स्टार्ट होगा, मान ले लेंथ कितनी है, 1 2 3 है, 2 तक जाएगा, 0 1 2, 0 के लिए 0 1 2, आएगा 1 5 9, फिर 1 के लिए 0 1 2, फिर आएगा 2 6 10, ऐसे होगा ना? हाँ ऐसे ही होगा, चल करके देखते हैं, वो ज़्यादा सही समझ आएगा ना। 0 0 0 0 No frame has been dropped till now. Latency seems to be good. Let's get cracking. चल मैंने एक नया फंक्शन बनाया, स्टैटिक void print 2D for int I equals to 0. चलो मैं वन बेस्ड इंडेक्सिंग करता हूँ. मैं आई यहाँ पे मैट्रिक्स यहाँ डिफाइन करता हूँ. ये मैट्रिक्स कैसे पहचान पाएगा? उसमें कैसे पहचान पा रहा था? कर लेनी यार, हम साथ में तूफान ला रहे, हाई तो है इतनी है, शो मेरा गवाही भरे, कुछ भी ना करे पर करे तो तबाही करे. आर्ग्यूमेंट ले रखा था. ज्यादा नहीं दिखे पर दिखे तो फिर देखनी हाथों मेरे. क्या चल रहा है यार? कंपाइल हो गई. तो इंडेक्स आउट ऑफ बाउंड्स का एरर आ गया है. कहीं तो लूप हो रहा है जो परमिसिबल वैल्यू से ज़्यादा हम कर रहे हैं. पहले तो सारी इंडेक्सिंग ज़ीरो बेस्ड करो. कुछ ऐसा ही चाहते थे हम। मैट्रिक्स तो नहीं लग रहा, बट हाँ यही होगा जो होगा। क्या चाहिए भाई, ये हो गया। प्रिंट 2D एरे मैट्रिक्स जावा, इतना ही था। हाँ इतना ही था भाई, ये तो हो गया। Coming to this problem. क्या कर रहा है भाई, वो बाजू के टाइम में खुला भी हुआ था। अप्रोच तो देख रखी है मैंने। मुझे कुछ ऐसा करना है कि जब मैं खुद ये 16 डिजिट एंटर कर रहा हूँ ना, मैं खुद इनमें से किसी में ज़ीरो डालूँ और उसकी वजह से उसके कॉरेस्पॉन्डिंग रो और कॉलम अपने आप ज़ीरो हो जाए, तो मेरे को आउटपुट मिलेगा। इसमें रो और कॉलम जो डाल रहा हूँ उससे जो इम्पैक्टेड हो गए वो सब ज़ीरो हो गए, ऐसा कुछ करना है। 1 0 0 0 0 0 0 0 ट्रैवर्सल करने का कोड बता भाई। कुछ ऐसे अगर इसी में हम लगा दें कि ये जो सारे घूम रहा है नंबर्स, करते हैं भाई कुछ, मर थोड़ी जाऊँगा। तो किन्ने राज राणे क्या करना है भाई। अगर मैट्रिक्स आई जे 0 है तो उसको रिप्लेस कर देना -1 से, समझ रहा है? मैं यहीं डाल दूँ तो F equals to 0। इत्थे ही रह जाना, इत्थे ही रह जाना, इत्थे ही रह जाना। क्या वेरिएबल में कर रहा है भाई तू? F मैट्रिक्स J 0 -1 करके देखता हूँ, होना चाहिए। चल चल तू अपनी, मैं तुझे पहचान लूँगा, मैं अपनी महफिलों में सिर्फ तेरा ही नाम लूँगा, तुझे पसंद धीमा रह जा और बस खामोशी। अब इसमें तो कुछ था ही नहीं ना बे, अब रुक जा, तेरा सारा सिस्टम पाड़ दे। बेटे वॉच कर दिया, वॉच ये तो क्या हो गया ना, -1 हो गया। अब जो पहला कॉलम है, पहले कॉलम में कॉमन पता क्या, सबका J0 है, समझे, सबका J0 है। राजे राणे if J equals to -1, ये दूसरे रूप में होना चाहिए यार, इसमें डाल दूंगा ना फंक्शन, बहुत कंफ्यूजन हो जाएगी। इसके अलग फंक्शन बनाना पड़ेगा, स्टैटिक वॉइड मेक फुल 0, मॉडिफाइड मैट्रिक्स, ठीक है, जहाँ जहाँ पर भी -1 आ रहा है, इत्थे ही रह जाने इसने कैसे कर रखा है फंक्शन में आके है क्या कर रहा है भाई तू मजाक है क्या भूले थे पैनर खाने यार बताना कि मैं गलत सोच रहा हूँ या नहीं ये भी तो लूप से हो सकता है अगर मैंने बोला कि यार सेकेंड रो में वो एलिमेंट है जो ज़ीरो है ठीक है और बाद में मैंने उसको -1 सेट किया तो सेकेंड रो के जितने भी कॉलम है 1 2 3 सब में जो मैं 2 ऑफ 0 2 ऑफ 1 मतलब सेकेंड रो 0th कॉलम सेकेंड रो फर्स्ट कॉलम सेकेंड रो सेकेंड कॉलम ये सब ज़ीरो हो जाए मतलब मैं रो को कॉमन रख के कॉलम पे ट्रैवर्सल क्यों नहीं लगा सकता है ना पर अब ये मेरे को सोचना तो आ रहा है करना क्यों नहीं आ रहा और कैसे आएगा And if you ask me, his daddy's gonna buy you a mockingbird. I'ma give you the word. I'ma buy a diamond ring for you. I'ma sing for you. I'll do anything for you to see you smile. And if the mockingbird don't sing and the ring don't shine, I'ma break that buddy's neck. I'll go back to the jeweler who sold it to you and make him eat every carrot or fuck with that. Google, Amazon, Denso. Hut. अच्छा एनालिस्ट होती है ओके makes sense to me right now. Hey Liano, you miss your mom. I know you miss your dad when I'm gone, but I'm give it back to them. I can see you sad, even when you smile, even when you laugh. I can see. But she loves you, girl, and you better know it. World we got in this world when it spins, when it twirls, when it twirls, when it twirls. So little beautiful girls, so looking puzzled in a day. I know what's confusing you. थोड़े गाने चलाने दे सोनम बाजो ये कौन सा एनालिस्ट कैसे सपोर्ट करते हैं
ਉਹ ਫੁਕਣੀ ਹੁਣ ਤੇਰੇ ਕੋਲੋਂ ਹਿੱਟ ਹੋ ਗਈ ਦੁੱਗਣੀ ਕੰਮ ਕੁਮ ਛੱਡ ਕੇ ਦੀ ਪੇਕੇ ਕਰ ਲਾ ਗੱਲਾਂ ਜੀ ਜਦੋਂ ਆਉਣਾ ਯਾਰ ਨਾ ਲਿਆ ਕੁਲੀਆਂ ਲਾਉਂਦੇ ਯਾਰ ਵੇਲੀ ਵਲੀਏ ਤੇਰੇ ਲਈ ਨੀ ਰੱਖੀਆਂ ਗੱਡੀਆਂ ਯਾਰਾਂ ਬਾਰੇ ਬੋਲਾ ਕੁੜੇ ਪਹਿਲੀਆਂ ਵੀ ਇਸ ਗੱਲੋਂ ਛੱਡੀਆਂ ਤੇਰੇ ਯਾਰਾਂ ਦੇ ਬਾਰੇ ਬੋਲਾ ਕੁੜੇ ਪਹਿਲੀਆਂ ਵੀ ਇਸ ਗੱਲੋਂ ਛੱਡੀਆਂ ਯਾਰਾਂ ਬਾਰੇ ਬੋਲਾ ਕੁੜੇ ਪਹਿਲੀਆਂ ਵੀ ਇਸ ਗੱਲੋਂ ਛੱਡੀਆਂ ਮੇਰੇ ਯਾਰਾਂ ਦੇ ਬਾਰੇ ਬੋਲਾ ਕੁੜੇ ਪਹਿਲੀਆਂ ਵੀ ਇਸ ਗੱਲੋਂ ਛੱਡੀਆਂ ਬੋਲਾ ਕੁੜੇ ਛੱਡੀਆਂ ਚੱਕਣਾ ਨੀ ਅਸਲਾ ਐਗਲਾ ਕਰਾਵੇ ਨਾ ਹੀ ਰਾਜੀ ਲੜ ਕੇ ਕਰਦਾ ਸਕੇ ਨੀ ਨਾਮ ਚ ਫੜ ਕੇ ਅੱਖ ਦੀ ਕੋਈ ਅੱਖੂ ਮੇਰੀ ਜਾਨ ਦੇ ਉੱਤੇ ਅੱਖ ਦੇ ਇਸ਼ਾਰੇ ਨਾਲ ਮੋੜਦੇ ਆ ਦੁੱਖ ਤਾਂ ਸੁਣਾਰੀ ਸਾਰੇ ਤੋੜਦੇ ਆ ਤੋੜਦੇ ਆ ਤੋੜਦੇ ਆ ਦੁੱਖ ਤਾਂ ਸੁਣਾਰੀ ਸਾਰੇ ਤੋੜਦੇ ਆ ਤੋੜਦੇ ਆ ਤੋੜਦੇ ਆ
क्या कर रहा है भाई तू जीवन में? तेरा इस दुनिया में आने का उद्देश्य क्या है? लास्ट लेग बाकी है.
got 0 if you carefully see, and everyone over here got 0 apart from these two elements. And this is how easily you can do it. Got it? So how the brute force code look like? We know we need a column of size m to keep a track, so I'll mark everyone as 0, and we know we need a row size n to keep a track of everyone who's 0. Now I will start iterating. So if you have to iterate on the matrix, first I'll go from 0 to n, then I'll go from 0 to m. Perfect. Then what is the next job? If that element at ij is 0, I know the row I will go ahead and get marked as 0, and the column j will go ahead and, marked as 1. Both have been marked, and this is how you can iterate and mark it. Once you have done that, you again reiterate. Yes, you again reiterate from 0 to n, and this time you convert the ones to zeros who are marked. So what you say is, if you are marked, if your row is marked, or your column is marked, if anyone is marked, I do not care. You will be 0 for sure, because the entire row is marked, or the entire column is marked. If that's the case,
दुनियादारी तो जो तराश बन गए अपने ते रख विश्वास बन गए हैं आम जय मुंडे भी ने खास बन गए हैं आम जय मुंडे भी ने ठोकरां बदामां नाल तेज हुंदियां
market. Once you have done that, you again reiterate. Yes, you again reiterate from 0 to n. And this time, you convert the ones to zeros who are marked. You convert the ones to zeros who are marked. So what do you say is, if you are marked, if your row is marked, or your column is marked, if anyone is marked, I do not care. You will be 0 for sure, because the entire row is marked or the entire column is marked. If that's the case, you will be this, and this is how. Over here, they're asking us to return a matrix. That is why I'm returning. If it's a void function, then you can just change to this particular matrix, which we are doing, and we do not need to return anything. So coming back to this particular matrix, which we are doing, and we
मैम इसने क्या किया, रो को एक 1D array लिया, कॉलम को एक 1D array ले लिया. अच्छा, भाई लीड कोड का ये इजी है, बहुत है बढ़िया.
Show mercy on it. ਦੋ ਕੁੜੇ ਮਹਿਗਨਾ ਨੀ, ਚਾਰ ਜੀ ਵਹਿਗਨਾ ਨੀ, ਉੱਤੇ ਨੂੰ ਮੈਂ ਸ਼ੀਸ਼ੇ 'ਚ ਚੱਕੀਆਂ. ਟਾਈਮ ਲੱਗੂ ਮਿਟਣੇ ਨੂੰ, ਸਾਨੂੰ ਥੱਲੇ ਸਿੱਟਣੇ ਨੂੰ, 21 ਵਾਰੀ ਜ਼ੋਰ ਲਾ ਲੈ ਛੱਤੀਆਂ. ਮੈਂ ਨੀ ਇੱਕੋ ਲਾਦਾ, ਮੈਂ 10 ਵਾਰੀ ਮਾਰਦਾ, ਮੈਂ ਉਹਦੇ ਉੱਤੋਂ 100 ਦੀਆਂ ਗੱਥੀਆਂ. ਟਾਈਮ ਲੱਗੂ ਮਿਟਣੇ ਨੂੰ, ਸਾਨੂੰ ਥੱਲੇ ਸਿੱਟਣੇ ਨੂੰ, 21 ਵਾਰੀ ਜ਼ੋਰ ਲਾ ਲੈ ਛੱਤੀ. ਪਲ ਕੱਢ ਤਾਰੇ ਕਹਿੰਦੇ ਹੁਣ ਟੁੱਟੇ ਨਾ ਕਰੀਜ, ਪੂਰਾ ਰੱਖਿਆ ਸਮਾਨੇ ਸਾਨੂੰ ਉਹਦੀ ਨੀ ਤਮੀਜ਼. ਆ ਲੈ ਤੈਨੂੰ ਦਿੱਤੀ ਸਾਂਭਲਾ ਨੀ ਬੇਬੇ ਵਾਲੀ ਚੁੰਨੀ, ਬੈਠਾ ਡਬਗਾਰ ਵਿੱਚ ਪਾ ਕੇ ਬਾਪੂ ਦੀ ਕਮੀਜ਼. ਬਾਲਾ ਦੂਰ ਨੀ ਰਕਾਨੇ ਹੁਣ ਰਾਂਝੀਆਂ ਨੂੰ ਖੇੜਾ, ਨਾ ਨੇੜੇ ਨੂੰ ਲਗਾਵਾਂ ਬਸ ਝਾਕਾ ਹੀ ਬੜਾ ਮੇਰਾ. ਬਾਹਰ ਰੁਕਾਂ ਨਾ ਰਕਾਨੇ ਕਿਤੇ ਮਾਰਾ ਇੱਕ ਫੇਰਾ, ਨੱਡੀ ਤੋਂ ਬਲ ਖਾ ਕੇ ਦਿੱਤਾ ਇੱਕ ਵਾਰੀ ਗੇੜਾ. ਕਿੱਥੇ ਤਵੇਂ ਰਕਾਨੇ ਨਾ ਦੇਖ ਲੈ ਦਬਾ ਕੇ, ਤੇਰਾ ਸ਼ਾਪਿੰਗਾਂ ਮਿਲਾਨੇ ਅਫਗਾਨੇ ਵਾਲੀ ਨਾ ਕਿ ਤੇਰਾ ਹੱਥ ਚੀਰ ਕਰਨੇ ਚੇਂਜ ਕਰਦੇ ਮਹਾਰੀ. ਜੁੱਤੀ ਪੈਰਾਂ ਵਿੱਚ ਪਾਵਾਂ ਤੇਰੇ ਪੈਰ ਸੂ ਮਗਾ ਕੇ, 3 ਮਹੀਨੇ 3 ਚੀਜ਼ ਨੇ ਲਕੀਸ਼ ਨਾ ਰਕਾਨੇ, ਨਿਤ ਯੂਈ ਤੋਂ ਯੂਕੇ ਨੂੰ ਰਟੀਸ਼ ਨਾ ਰਕਾਨੇ. ਮੈਂ ਤਾਂ ਰੁਕ ਜਾ ਦਿਮਾਗ ਸਾਰਾ ਰੁਕਦਾ ਨੀ ਮੇਰਾ, ਤਾਂ ਹੀ ਲਾ ਲਈਏ ਸਮਾਧੀ ਮੈਡੀਟੇਸ਼ਨ ਨਾ ਰਕਾਨੇ. ਲੋਕੀ ਸਾਡੇ ਕੋਲ ਸਿੱਖੋ ਹੁਣ ਸਾਨੂੰ ਦੇਣ ਮੱਤਾਂ, ਸਾਨੂੰ ਕਿੰਨਾ ਕੁਝ ਦੇ ਗਈਆਂ ਨੀ ਮਿੱਟੀ ਦੀਆਂ ਵੱਟਾਂ. ਕਿੱਥੋਂ ਲੰਗੇ ਤੇਰਾ ਯਾਰ ਮਾਰੇ ਕੈਮਰਾ ਫਲੈਸ਼, ਹੁਣ ਖਿੱਚਦੇ ਨੇ ਫੋਟੋ ਕਦੇ ਖਿੱਚਦੇ ਸੀ ਲੱਤਾਂ. ਇਹਦੀ ਅੱਖ ਨਾ ਲੱਗੇ ਵੇ ਜੱਤੀ ਮਰੀ ਤੇਰੇ ਉੱਤੇ, ਸਾਨੂੰ ਸਦਾ ਨੇ ਬਣਾ ਗਏ ਨੀ ਹਾਲਾਤ ਸਾਡੇ ਪੁੱਠੇ ਤੋਂ. ਆ ਹੁਣੇ ਤਾਂ ਗਿਆ ਗੀ ਬੀਬਾ ਨੀਂਦ ਰਾਏ ਉਡਾ ਕੇ, ਸਾਨੂੰ ਕਈ ਸਾਲ ਹੋ ਗਏ ਨੀ ਉਹ ਚੰਗੀ ਤਰ੍ਹਾਂ ਸੁੱਤੇ. ਹਾਰ ਕੇ ਤੇ ਨਹੀਂ ਰੱਖਾਂ ਸਾੜ ਕੇ ਰਕਾਨੇ, ਇਹਦੇ ਮੁੰਡਰਾਂ ਨੇ ਯਾਰ ਪੱਟੂ ਕਾੜ ਕੇ ਰਕਾਨੇ. ਤੇਰੇ ਫੁੱਲਾਂ ਦੇ ਮਰੇ ਨੇ ਮੈਂ ਵੀ ਇੱਕ ਐਮ ਲਾਤਾ, ਹਲੇ ਨਵੀਆਂ ਫਰਾਰੀ ਜੁੱਤੀ ਝਾੜ ਕੇ ਰਕਾਨੇ. ਦਿਲ ਤੋੜਤੇ ਮੈਂ ਸ਼ੀਸ਼ੇ ਸਾਕ ਮੋੜਤੇ, ਕਤਾਰਾਂ ਵਿੱਚ 18 ਹੋਰ ਪੱਕੀਆਂ. ਦੂਰੋਂ ਮੱਥਾ ਟੇਕਦੀਆਂ ਮੁੜ ਮੁੜ ਦੇਖਦੀਆਂ, ਅਸੀਂ ਨਹੀਂ ਉਹ ਇੱਕ ਵਾਰੀ ਤੱਕੀਆਂ. ਇਹਨੇ ਇੱਕੋ ਨਹਾਰਦਾ ਮੈਂ 10 ਵਾਰੀ ਬਾਹਰਦਾ, ਮੈਂ ਉਹਦੇ ਉੱਤੋਂ 100 ਦੀਆਂ ਗੱਤੀਆਂ. ਟਾਈਮ ਲੱਗੂ ਮਿਟਣੇ ਨੂੰ, ਸਾਨੂੰ ਥੱਲੇ ਸਿੱਟਣੇ ਨੂੰ, 21 ਵਾਰੀ ਜ਼ੋਰ ਲਾ ਲੈ ਛੱਤੀਆਂ. ਉਹ ਕੁੜੀ ਜੱਟ ਦੀ ਬਣਾਈ ਰਹਿ ਸਕੂਰ ਤੋਂ ਪਛਾਣੇ, ਅਸੀਂ ਆਸ਼ਕੀ ਚ ਨਵੇਂ ਨੀ ਸ਼ਿਕਾਰੀਆਂ ਪੁਰਾਣੇ. ਗੜ ਸੁੱਕਦਾ ਕਿੰਨੀ ਤੂੰ ਜਦੋਂ ਸੁਪਨੇ ਚ ਆਵੇਂ, ਮਿੱਟੀ ਉਦੋਂ ਦੀ ਸੁਣਦੀਆਂ ਪਾਣੀ ਰੱਖ ਕੇ ਜ਼ਰਾਣੇ. ਮੈਂ ਕਹਿ ਚੱਲਦੇ ਰਕਾਨੇ ਸਿੱਕੇ ਮਿੱਤਰਾਂ ਦੇ ਖੋਤੇ, ਆ ਕੇ ਬਹਿੰਦੇ ਰਕਾਨੇ ਚੀਨੇ ਮਿੱਤਰਾਂ ਦੇ ਕੋਠੇ. ਤੈਨੂੰ ਸੋਹਣੀਏ ਰਕਾਨੇ ਕਰਾਂ ਹੱਥਾਂ ਨਾਲ ਸ਼ਾਮ, ਜਿਵੇਂ ਕਰਦੇ ਨੇ ਸ਼ਾਮਾਂ ਸਾਡੇ ਪਿੰਡਾਂ ਦੇ ਬਲੋਟੇ. ਤੇਰਾ 100 ਤੋਂ ਪਰ ਬਾਰਾ ਹੋ ਗਈ ਢਿੱਲੀ ਕੁਝ ਖਾ ਕੇ, फिल्मा बना के काफी कर ली कमाई काफी मित्रा ने डाली थोड़े हमला रकाने लैंबो नीवी करवाली नਵੇਂ ਸ਼ੋਰਾਂ ਤੋਂ ਰਕਾਨੇ ਗੱਡੀ ਚੱਲਦੀ ਨਹੀਂ ਸਿੱਧੀ ਲਾਦਾ ਮੀਚ ਕੇ ਖਾਨੂੰ ਬੈਕ ਗੰਨੇ ਦੀ ਟਰਾਲੀ ਲੱਗੇ ਗੱਪਰੂ ਦੀ ਤੋੜ ਕੁੜੀ ਟੁੱਟੀ ਪਈ ਨੂੰ ਆਵੇ ਇਹ ਜਨਾਰ ਦੀ ਫਸਲ ਜਿਵੇਂ ਫੁੱਟੀ ਪਈ ਨੂੰ ਆਵੇ ਮੇਰੀ ਯਾਦ ਦੀ ਮਾਰੀ ਉੱਤੇ ਨੂੰ ਹਿੱਚ ਕੀ ਰਕਾਨੇ ਸੱਚੀ ਮਾਰਸ ਦੇ ਗਾਣੇ ਵਾਂਗੂ ਸੁੱਤੀ ਪਈ ਨੂੰ ਆਵੇ ਬੇਚੈਨ ਹੋ ਗਈ ਇੱਕ ਕੁੜੀ ਪਹਿਨ ਹੋ ਗਈ ਔਜਲੇ ਦੇ ਕੰਨਾਂ ਵਿੱਚ ਨੱਤੀਆਂ ਕਰੀਦੀ ਨਹੀਂ ਕਹਿਰ ਕੁੜੇ ਗੌੜਦੇ ਨਹੀਂ ਸ਼ਹਿਰ ਕੁੜੇ ਪਿੰਡਾਂ ਹੁਣ 12 ਵਾਰੀ ਇਕੱਠੀਆਂ ਮੈਂ ਨਹੀਂ ਕੁਨਾਰਦਾ ਮੈਂ ਅਸਮਾਰੀ ਬਾਰਦਾ ਮੈਂ ਉਹਦੇ ਉੱਤੋਂ 100 ਦੀਆਂ ਗੱਤੀਆਂ ਟਾਈਮ ਲੱਗੂ ਮਿੱਟਣੇ ਨੂੰ ਸਾਨੂੰ ਥੱਲੇ ਸਿੱਟਣੇ ਨੂੰ ਇੱਕੀ ਵਾਰੀ ਜ਼ੋਰ ਲਾ ਲੈ ਛੱਤੀਆਂ
मैं घड़ी चार्ज पे लगा के आया, ठीक है, फिर करते हैं इसका।
ਟਾਈਮ ਲੱਗੂ ਮਿਟਣੇ ਨੂੰ ਸਾਨੂੰ ਥੱਲੇ ਸਿੱਟਣੇ ਨੂੰ ਕੀ ਵਾਰੀ ਜ਼ੋਰ ਲਾ ਲੈ ਛੱਤੀਆਂ
वाइट बोर्ड क्या होता है भाई? वाइट बोर्डिंग राउंड क्या कर रहा हूँ मैं?
we have a -1. Thereby we will not do anything. Had we marked for the 0, 0, we would have ended up marking this, which would have been wrong. 1, -1, 0. Okay, we have a 0. So entire thing and then this entire thing. So this will be -1, rather -1, and this will be -1. Perfect. Next, this one, next this one, next this one, next this one, next this one. Once you have done this, now what do you know? For these zeros, whoever was to be marked, they have been marked -1. So let's do one piece of iteration more. Yes, let's do one piece of iteration more. And what we will do is, we'll just convert them to zeros now. We will just convert them to zeros. And once you have done this, I can say, this is my final array and this will be my brute force solution. Quite simple, just we have to be careful. It's not about doing what they have said because that might cause an issue. So thereby we will just introduce something as -1 in the brute force solution. So I have to write the code for the brute force solution. So you know, in order to traverse, we first traverse from 0 to n, then we traverse from 0 to m. This is how you usually traverse in a 2D matrix. And then what you do is, you say if there's a 0 on that particular place, we go to the ith row and mark that. That means this portion. Then we go to the column, that means this portion, and we mark it. And you have to write these couple of functions separately. So let's quickly write it. So the mark row function will be very simple. It takes a row number and then it iterates for the columns. And in every ij which is non-zero, do not mark the zeros. In all the non-zeros, you can just assign -1. Similarly, there will be a mark column which takes the column number and iterates for every row and marks that column as -1 if it's a non-zero. So this code will make sure that everything that is a 0, in that particular column, everything will be marked as -1, and in that particular row, everything will be marked as -1, apart from the zeros. Got it? So once we've done this, what's the next job? The next job is just to iterate in the matrix, and whoever is -1, turn it into 0. So let's quickly do it. So this will be the final piece of code where we iterate in the matrix and we say if it's a -1, please convert it into 0. So what will be the time complexity of the brute force solution? Can I say over here it's n into m? And inside, can I say this is taking big O of n and this is taking big O of n because there are two loops that are running. So thereby, it's something like n into m into n plus m, very important, into n plus m, plus you're again doing an iteration of n into m in order to initialize them to zeros. So this is the overall time complexity and it's somewhere to the power of q, somewhere to the power of q. If you carefully see, this and into this will be somewhere near about the power of q, and the interviewer will not be happy with it and he will say that this is not accepted, and that's when you move to the better solution. So let's quickly check out the better one. So we gave a brute force solution to the interviewer which was taking a time complexity in the order of n cube. And why was it taking a time complexity in the order of n cube? Because we were traversing in the array and that was taking n square, like in the order of n square, n into m. And then what we did was, for every 0, we went across the entire column and the entire row and we marked every one as 0. So this is where we were taking that extra time for going across the column and going across the row. So what do we need to eliminate? Because if the interviewer is asking us to optimize, the optimal solution will definitely not be n cube. We need to optimize this. In order to optimize, we might be able to get an n square or somewhere around n square. That's for sure. This is where we need to think, what do we need to eliminate? We need to eliminate this and we need to eliminate this. How can I? Now can I say, what was I doing? I was going across and marking everyone as 0. I will not do that. Instead of that, I'll think, for this one to be 0 in the final matrix, for this one to be 0 in the final matrix, why will it be? I'll be like, if this entire column has a minimum of 1 0, can I say, if it is a minimum of 1 0, or if this entire row has a minimum of 1 0, agreed, because this 0 will convert this to 0, even this 0 will convert, but what I need is just 1 0. And so can I say, if there is a 0, instead of going across the entire column, I will say if there is a 0, I will mark it. I'll mark this column, because at the end of the day, everyone will be 0 in this column, that's for sure. So I'll just keep a track. This column is done and dusted. At the end of the day, everyone will be 0. Similarly, if there is a 0, this row is done and dusted. Everyone will be 0 at the end of the day. So instead of marking them at the current time, I'll say, let's probably keep a track. And by the end of the day, I will mark it. This is how my thought process will be. So to have that thought process converted into algorithm, what I'll do is, I know that for the 0, I'll have to mark it, and for the 0, I'll have to mark it. So there has to be 4 column array, correct, which will keep a track if the column is marked, and there will be a 4 over here, 4 size row array, which will again keep a track if the row is marked or not. So I'll go ahead and create a m size, yes, very important. I will create a column array of m size, because those many are the number of columns, and I'll create a row array of n size. Over here n and m are same, and what I'll do is, initially I will mark every one of them as 0. 0 means they're yet not touched, and now I'll start iterating. First, no, 1, no, 1, no, 1, no, 1, no. You will not do anything when there's a 1. And then you go ahead and see there's a 0. So whenever there's a 0, you know this entire column is done and dusted. At the end of the day, everyone will be 0. So please go ahead and say, I will mark it. Marking it means 1. Perfect. And you know, everything in this row will also be marked. So you mark it as 1. Perfect. 1, 1, 1, 1. 0 again. 0 means everyone in this column and everyone in this row. Go ahead and mark it. So you'll mark it. Perfect. Next, 1, 1. Again a 0. This 0 means this one is marked and this one is marked. So go ahead and mark it. Perfect. Next, this 0 means this one is marked and this one is marked. Next, this done. So what I've done is, for every 0, I've ended up marking which columns and which rows will be 0. Now what I will do is, I will do a reiteration. Yes, I will do a reiteration. Let's quickly do the reiteration. So whenever we are at 1, we are like, okay, wait, will I be a 0? I will only be a 0 if this or this is marked. Is this marked? No. Is this marked? No. So I stay 1. I stay 1. Okay. I will say 1, I'll only be 0 if this is marked. I'm like, yes, I'm marked. So I'll end up getting 0. Perfect. Next, I have 1. Oh, this is marked. So I'll end up getting 0. Next, 1. 1. Not marked, so stays. Next 1. Not marked, but marked here. So this will be a 0. Next, 0, nothing to do. 1 marked, so this will be a 0. Next, 1 marked, so this will be a 0. Next 1 marked, so this will be a 0. Next 1 marked, this will be a 0. 0, nothing to be done. This one marked, this will be a 0. This one marked 0. This one marked 0. This one marked 0. This one already a 0. So what we got to know was, this entire thing got 0 if you carefully see, and everyone over here got 0 apart from these two elements. Apart from these two elements. And this is how easily you can do it. Got it? So how the brute force code look like? We know we need a column of size m to keep a track. So I'll mark everyone as 0. And we know we need a row size n to keep a track of everyone who's 0. Now I will start iterating. So if you have to iterate in the matrix, first I'll go from 0 to n, then I'll go from 0 to n. Perfect. Then what is the next job? If that element at ij is 0, I know the row I will go ahead and get marked as 0, and the column j will go ahead and, marked as 1 rather. Marked as 1. Both have been marked, and this is how you can iterate and mark it. Once you have done that, you again reiterate. Yes, you again reiterate from 0 to n. And this time, you convert the 1s to 0s who are marked. You convert the 1s to 0s who are marked. So what you say is, if you are marked, if your row is marked, or your column is marked, if anyone is marked, I do not care. You will be 0 for sure, because the entire row is marked or the entire column is marked. If that's the case, you will be this, and this is how the code will look like. Got it? So in case you have tried out the problem, the link will be in the description, and if you want the C++, Java and Python code, all the links will be in the description. Remember one thing, over here they're asking us to return a matrix, that is why I'm returning. If it's a void function, then you can just change to this particular matrix, which we are doing, and we do not need to return anything. So coming back to the iPad again, what is the time complexity? Can I say this is taking bgo of n cross m, and so is this. Therefore the time complexity is bgo of 2 cross m for sure. What about the space complexity? The space complexity is nothing but bgo of n and bgo of m. for the two arrays that you're using for
Can you
hashing.
do better?
This is where the interviewer will not be happy because you're using an extra space and he will ask you to optimize the better solution and you will move to the optimal one. Over here, can you optimize the time complexity? We are already doing it in the order of n square. And we know the minimum in order to traverse a matrix can be n square. You cannot do better than that. That's why we will be focusing to optimize the time complexity. And let's get back to the matrix. We were taking a column and we were taking a row. Agreed? So if I was taking a column and if I was taking a row, if I have to optimize it, what does that mean? That means you have to do everything in the matrix itself. So what I'll start thinking is, can I keep a track in the matrix itself? Can I just probably keep a track in the matrix itself? And that's when I start thinking, what if I say, hey, maybe instead of taking a row outside, what if I consider the first column to be my row? Like instead of taking here, I moved it inside. Probably in place, I moved it inside. So what I'm saying is, row or at the column of 0 will become my row, which I was taking. Probably yes. And now I'll say, probably instead of taking this, I'll move it inside. Maybe because I have to do it in the matrix. So that's a possible solution. The row 0 is what I will now consider as column of m size. That's my first assumption. But can I take it? Let's see if that's possible. So what am I saying? The things that I was marking here, like for the 0, if I was marking here, and instead of marking here, I'm taking this and I'll mark it here. That's what I'm saying. Correct? But is it correct? It's not correct. Why? Because, okay, I understood it. You took the column inside and that's how it looks. But you took the row also inside. And now there is one single point which acts as the same. And if you remember the better approach, there was a row here and there's a column here. And everyone was individual. This point and this point were individual. But if you take them inside, what happens is, this is one and this is one. And this is a single point where it's a common point. So what I'll say is, it's about one point, na? I'll apply my blade. And I'll say, okay, well, let's keep the row as row. So I'll keep the row as row. Perfect. And the column I'll take till here. I won't take the entire column. I'll take till here. But then I'll be like, what will happen to this one? Like, who will keep the track of this? Because instead of this, what you're doing is you're just taking this. So what happens to this? I'll say, okay, this one is a single element. Nah? It's a single element. Nah? I will probably extend this to something like this. Can I do this? I'll call it as a column variable. Let's just call it as a column variable. Can I call this? Because this is an extra part. This is an extra part. So the row stays as row. And I take this much. And for this, since it is colliding, put it into a variable. Now there is no collision. It works. Works fine for me at least. So now what I'll do is, I'll try to probably draw the figure. It's something like this. And then I go like this. And I go like this. Perfect. That's how the column array will look like. And it's more like, maybe I can call it as column 0 and mark it as 1. And this will be my row. Do you agree? You do, right? So this will be my row. The same brute force I'm trying to optimize. Look at the intuition. Okay, now let's start iterating and let's try to do the same things that we did. But before that, let's keep something in mind. This 0 will mark everything here and mark everything here. Agreed? This 0 will mark everything here and mark everything here. Agreed? This 0 will mark everything here and everything. So if you remember, so if you see, everyone will be converted to zeros only apart from this corner guy. Keep this in mind that this corner guy will not be converted. Keep this in mind, it will be very very useful in the next part when we figure some edge cases. Keep this in mind, the corner is not converted. Okay, let's start creating in the matrix. We have a 1, right? What happens to this one? This one says, I'm a 1, so I do not harm anyone. Let's move. I'm a 1, I do not harm. I'm a 1, I'm a 1, I'm a 1, I do not. But he's a 0. He's like, what did I do? I'll keep a track. So I'll mark it here and mark it here. And I know who is this guy? This guy? Who is this? This one. So I will now go and convert them to zeros. Perfect. Next, I have a 1, 1, 1, 1, 0. This 0 was marking it here and marking it here. So instead of this, I'll mark it here. Perfect. Next, 1, 0. Now this 0 was apparently marking it here and was apparently marking it here in the column array. What will happen now? Instead of here, it will mark here, and it's already a 0. That's okay. And instead of here, it will mark here. So this will make it 0. Perfect. Next, we have a 1, we have a 1, we have a 1. So the iteration is completed. Once the iteration is completed, what is the next step? To convert all the ones to zeros who are marked, correct? To convert all the ones who are zeros. This is why you have to remember. In the answer, only this one was not converted. So, if I'm trying to convert this, whom do I check? I check in this and I check in this, correct? For this one, I see the column 0 is 0. So this will be 0, right? Because it's marked. If you remember, for this, we will check this, and the column 0 is 0. So this will be converted to 0. But, here comes the twist. If you convert this to 0, hypothetically just assume you converted this to 0. And the twist is, if you convert this to 0, what will happen is, now when you go to this one, okay, this one will say, I will be converted to 0 if this is 0 or this is 0. And what will happen is, it will find here 0 and it will convert this to 0, which is wrong. Because this row means this. So thereby, you cannot start from these elements. You cannot start from these, then keep them for later. Because as of now, if you change the values, that will impact the matrix. Do not change their values. Instead, try doing from these places. Did you understand? I hope you did, right? So what I'll do is, I will not touch them as of now. And I will start going probably from here, then to here, then to here. And then we can deal with this separately. Got it? So let's start. This one, will it be marked? No, it's a 1, but it's a 0. So this will be marked. Perfect. This one, it's a 0. Let's mark it. Next, this one, it's a 0. It's a 0. Mark it. Please do not do anything to the first rows and first columns. Please. Next, there's a 1. Will it be? No. Will it be? Yes. Next is already 0. Next, 0. Next, 0. Why? Because over here. Next, 0 because here. Next, 0. So what I've done is, I've converted each of them. Now it's time for the next. Okay, so the last section of this algorithm, and it's very important that you hear me out properly. So do you remember one thing? Initially I told you this is the only one who was not converted to 0. And everyone else would be converted to 0. Now tell me one thing. You have solved this portion. Will you solve this portion at first? Or will you solve this portion at first? Let's analyze. This portion's answer is dependent on who? One is this, and the other one is this. Correct? Agreed or not? You agree? So, this one is he himself. And this one is 1. So, it's dependent on this. So, if you solve this portion at first, the value might change. Which might hamper this, which might impact this. So, at first, you will solve this portion. Then you will solve this portion. Now, for this portion to be 0, this has to be 0, which is not the case. So this stays as 1. For this is already 0, and this is already 0. And we do not do anything else. Now for this portion to be 0, this one has to be marked, and this one has to be marked. And I see this is marked, so this will be 0. Convert it to 0. For this portion, it's 0, 0, 0. Done. So first, you solve here. Then you solve this, because it is dependent on this. Then you solve this. First, do not solve this, because if you change the values, that will impact the matrix. This was the thought process behind this particular algorithm. So let's quickly quote the optimal solution up, and this was the better solution.
करते हैं. ये कोड करके मैं गिटहब पे पुश करके सो जाऊंगा, ठीक है?